Hi, I'm Professor Melko, Chemistry PhD, and today we're going to talk about elements and the periodic table. Let's jump into the lecture. Elements have names, just like you and I, and each element has a unique name because it is unique and special. Names are given to these elements depending on sort of when they were discovered. This periodic table sort of breaks them into when they were discovered and how they were named. So you have elements that are named after Greek gods, like helium, named after the god of the sun, Helios. Latin origins like carbon, named after carbo, the Latin name for coal. And many elements named after people or places. We typically abbreviate elements with a chemical symbol. Okay? The symbols are 1 or 2 letters long. The first letter is always capitalized if there's a second letter, and there isn't always, but if there is, it's lowercase. So some examples here are C for carbon. So anytime you see the letter C in a formula, it stands for carbon. Unless that C is followed by a lowercase letter, CD, now this stands for a different element, cadmium. And so this is the scientist's shorthand for communicating different elements. In some cases, the symbol is not so straightforward. C for carbon makes sense. Gold is AU, which in English, there's not a clear delineation from gold to AU. That's because it comes from this Latin name, aurum. Similarly, lead comes from the fun word to say, plumbum, which is Latin, apparently, for lead. Right? So some of the elements, it's easy to remember their symbols. Some it's going to take you a little time and familiarity doing examples until you sort of internalize these symbols. Now, in my class, I make my students memorize the names and symbols of all of these elements. So not all of them on the periodic table, but most of them, okay? So basically everything in most of these rows stopping here. So students don't have to memorize any of these lanthanides, or any of these actinides. Okay, but all the other elements here, my students have to remember the name and the symbol that goes with them, right? So I need you to be able to say copper is Cu, right? Or krypton is Kr. So sometimes note cards can help with that memorization process. That's sort of my recommendation. So let's do a quick practice problem here and see if we can guess, recall, or go back and find the element abbreviations or the element names based on these abbreviations or symbols. So you can pause the video here and try yourself. I'm going to work through them now. H is hydrogen, the first element on the periodic table. SB is kind of a tricky one. It's antimony. Ni is pretty straightforward. You might guess this one. Ni stands for nickel. And Zn stands for zinc. Right? So some of these are somewhat easy to guess or learn. But some of them, like antimony, are going to take a little practice. Now, elements are categorized in different ways, just like we categorize different mixtures, like homogeneous and heterogeneous. Elements themselves get categorized. One of the way we categorize them is into metals, nonmetals, or semimetals. Okay? And sometimes you'll see semimetals referred to as metalloids. And these metalloids have properties, just like it sounds, in semimetal, halfway between metals and nonmetals. Okay, most of the periodic table is metals. So everything in blue here on the periodic table is a metal. Right, so most of these rows and most of these elements are metals. Okay. One confusing one is hydrogen. It's a nonmetal, but it's on the left with all these other metals. Otherwise, the remaining nonmetals are on the right side of the periodic table. And these are separated from one another with, you guessed it, these semimetals shown in orange. Now they're separated in this way because each of these different categories has different properties. Okay, metals are typically solid at room temperature. They have high melting points, they're very dense, and they have this shiny luster to them, right? And that should be familiar, right? You think of coins you might get that are made of metal, they're always shiny. They're good conductors of heat and electricity, right? We cook food a lot of times on metals because they heat up and conduct heat very, very well. They also conduct electricity, so we use metals like copper for electrical lines. Two more properties you might not be as familiar with are malleable and ductile, okay? And these are words we use in chemistry that sort of describe how you might change the shape of the metal. Metals are malleable because they can be hammered into a sheet. So that is the property of malleability, that I can hammer this metal out and make a sheet of it. Ductile is a similar process. You're not hammering it out, but you're drawing this metal into a wire, right? So the electrical lines that are made of copper wire, it is this ductile property of metals that allows us to do that without the substance sort of crumbling apart. Okay, so these are the properties of metal: strong, high melting points, shiny, good conductors, malleable, ductile. Nonmetals, on the other hand, have sort of the opposite type of properties. They have low melting points and low densities. They're not shiny, but they have this dull appearance, right? This powder at the bottom here is phosphorus. Right, so think of like a match head. That's a nonmetal. Poor conductor of heat and electricity. They're not malleable or ductile, right? If you try to hammer out a match head, it's going to crumble. It's not going to hammer out into a sheet, right? So this is what sort of defines nonmetals. They're usually solid or gas at room temperature. Turns out bromine is liquid at room temperature, the only nonmetal that is liquid. Similarly, if I go back, there is one liquid metal as well. Okay, but most nonmetals are going to be solid or gas at room temperature. So low melting points, not shiny, don't really conduct heat or electricity, aren't really malleable or ductile. Basically the opposite of metals. Semimetals, of course, have properties in between these two extremes. So maybe it's shiny, like pure silicon, but it's not a great conductor. If you try to hammer silicon apart or into a sheet, it is going to crack, right? So it's brittle, but it's shiny. Now, these are interesting elements because they sort of combine properties of each type, metal and nonmetal, and have really unique applications. So you can think of silicon chips that we use in computing, rely on these somewhat conductivity properties that are somewhere between completely conductive like a metal and completely non-conductive like a nonmetal. So take a second and try to categorize the following elements as metal, nonmetal, or semi-metal. Feel free to pause the video and take 30 seconds to try to answer this. I'm going to start with sodium. Okay, and using the periodic table to identify whether it's metal or non-metal relies on our knowledge of the symbol, right? The symbol for sodium is Na. If I find Na on the periodic table, it's over here. So this is sodium, it's on the left, it's going to be a metal. And you might not usually think about this, but sodium is in fact a metal. Chlorine, the symbol is Cl. It's found over here on the right side of the periodic table. This chlorine is a nonmetal. Okay, so you can remember where these elements are on the periodic table, or remember their symbol and find out where they are on the periodic table. Things on the left are almost always metals. Things on the right, almost always nonmetals. And then you have this staircase here of the semimetals. Now, this table I've been showing, of course, is the periodic table which organizes the elements. And they're numbered. You notice all these numbers, 19, 20, 21 over potassium, calcium, scandium. This is the atomic number, so elements are arranged by this atomic number. And we'll get into this much more in future lectures. But the organization of the periodic table, the shape that it is, actually stores a lot of information, right? So it turns out that things that are grouped together in these columns have similar properties, right? And the trends are periodic, hence the name periodic table. So we've looked at periodic tables thus far that sort of delineate metals, semimetals, and nonmetals. Here's a different periodic table that delineates solid, gas, liquid. Right? If you want to go back and review a previous video on the states of matter, we talked about the properties of solid, liquids, and gas and how those differ. So now this is superimposing on top of the periodic table what elements are solid, liquid, and gas. Okay? Most elements, as you see, are solid at room temperature. Mercury is a liquid, the only liquid metal at room temperature. Bromine is liquid, the only liquid nonmetal at room temperature. Okay? All the semimetals in here are solids. Okay? Most of the nonmetals over here on the right are gas. And the one exception on the left side of the periodic table that is not a solid is hydrogen, which is a gas. Okay? So these are different ways we can express the periodic table to categorize elements in different ways, and that'll do it for this lecture. Next lecture, we'll learn about chemical formulas, physical and chemical properties, and physical and chemical changes. As always, you can feel free to subscribe to my channel on YouTube. Catch me over on Twitch for weekly office hours and discussion of science news. But that'll do it for today's lecture. Up next again, we'll get into chemical formulas.